Hello everyone, this is Astrid at Optilogic. Today I want to tell you about an exciting new feature in Cosmic Frog's Hopper engine which runs transportation optimization. The feature is called territory planning. First I'll talk you through two quick slides to explain what territory planning is, and then we'll go into a template model within Cosmic Frog. If you want to follow along, you can download this template model from the resource library. Please see the link in the accompanying documentation. So with all that said, let's dive in. If you are tasked with route design and planning, you may find that assigning drivers to different geographical areas on different days or weeks does not provide the most efficient customer service, since the drivers are not familiar with all areas. In addition, predicting when the next delivery option is for a customer placing their order online may also be challenging. Using the new territory planning feature in Cosmic Frog's transportation optimization algorithm will help overcome these challenges, and I will show you today how you can easily add this to any pre-existing Hopper model. So what is territory planning? It is the automatic clustering of customers into geographic regions, which we call territories. This then restricts routes and drivers to operate within those boundaries of the territories. This leads to several key benefits, including operational efficiencies. As drivers become familiar with their assigned territories, they increasingly know the streets, traffic patterns, and customer locations very well, leading to faster deliveries and therefore improved customer service. The service windows also become more predictable. When we know which territories are served on which days, organizations can provide accurate delivery window estimates to customers at the point of purchase. Networks become easier to manage because having clear territories allows for local teams managing specific regions rather than having to coordinate across the entire network daily. And finally, better adaptation. If we enter a new market or we experience changes in demand, we can very easily redesign our territories to optimize for the current conditions rather than keep using territories based on outdated data. This slide provides a high-level overview of the territory planning feature. There's one new input table named Territory Planning Settings. On here we can specify the number of territories our network should have and provide constraints around the number of delivery locations, pickup locations, and the quantity delivered by territory. Solver Focus is a model run option and it now has a new high precision option. This needs to be used when running models using the territory planning feature, but it can also be used on any other Hopper model to improve the results. There are two new output tables named Territory Planning Summary and Territory Planning Assignments. The Territory Planning Summary contains for each territory by scenario its high-level KPIs. The Territory Planning Assignments table shows for each customer which territory it belongs to. Lastly, two new columns named Territory Name and Territory Type have been added to four already existing tables, including, for example, the Stop Summary and Segment Summary tables. This allows for easy filtering by territory within the tables and also for visualization by territory on the map. Now we have switched to Cosmic Frog, where we can see our template model named Territory Planning Template Model. We are in the Maps module to show the locations of this model. There's one facility, a distribution center in central Atlanta, and 100 customers around it. They are color-coded based on their predefined territory, which we will use in one of the scenarios. Moving over to the input tables in the data module. Input tables are selected. We're only showing those with populated records. 100 customers, as we've mentioned, one facility, one product. There's one transportation asset, which has a capacity of 24 units, and it uses a rate from the transportation rates table, which is $100 per route and $1 per mile distance cost. We're showing the shipments table, where we can see that each customer has one shipment set up. The quantity varies between 1 and 20 units. And the notes field is important to note. This contains the predefined territory that we want to use in one of the scenarios, and we will use the decomposition name To set this to the value of the modes field, the decomposition name field takes care of grouping the shipments with the same decomposition name into one territory. The new input table territory planning settings is shown here. We have two records for two territory types. One is named small territories, the other large territories. Number of territories is set to 5 and 3 respectively, and the minimum number of delivery locations for the small territories type is 18 per territory and 30 per territory for the large territories type. Important to notice that the status is set to exclude, so we need to change this via a scenario item to include if we want the territory planning feature to be used. Other constraints can be set here too, so the maximum number of delivery locations, min and max number of pickup locations, and also min and max delivery quantity. They are not used in this example model. The scenarios then, under the scenarios module. So we have a scenario called no territories, which uses all the input tables as they are. And here, since we are not using any territories, the routes will just be designed based on the lowest possible cost. This may mean that from an operational efficiency perspective, they are less optimal. The predefined territories scenario has one scenario item that sets the decomposition name field to the value of the nodes fields, which we have seen are those names of the predefined territories: central, north, east, south, and west. So they have been designed manually, and we want to see cost-wise how well those territories perform. And then the last two scenarios are 5 optimized territories, where the small territories that have been set up on the territory planning settings table are going to be included. The status is switched and filtered on territory type, the small territories. Similarly, the 3 optimized territory scenario will include the large territories, the 3 that will be designed based on the large territories type in the territory planning settings table. To run the scenarios, we click on the green Run button at the right top of the screen. This brings up the Run settings screen, and in the technology parameters under Transportation Hopper, we set Solver Focus to High Precision mode. This is needed, otherwise the territory planning feature will not be used. After the scenarios have completed running, we go back to the data module and look at the output tables. First one opened here is the transportation summary table, and we compare for the 4 scenarios that were run their total transportation cost. The predefined territories, where we manually designed the territories in north, east, south, west, and central, has the highest total cost, indicating that there's room for improvement in how these territories are set up. No territories, we did not require the customers to be clustered into territories, and this has the lowest overall cost as we expected, because the routes are purely designed on lowest cost. But this means this network could have decreased operational efficiency as compared to those with defined territories. Then 5 optimized and 3 optimized territories, where these scenarios were forced to have 5 and 3 territories respectively. They sit in between the previous 2 scenarios with their total costs, indicating we can improve on the manually designed territories, and the increased cost as compared to the no territories may be outweighed by the increased operational efficiency that these may provide. The territory planning summary output table is a new one, and by scenario we see that each territory is summarized. 5 small territories in the first 5 optimized territory scenario. And we see the number of delivery locations are 18 for 4 out of the 5 territories here, and territory number 1 has 28. The territory assignment summary output table is also new, and here by location name, which is customers in our case, we see which territory it belongs to. Transportation stop summary is one of the 4 tables to which 2 new columns have been added: territory name and territory type, all the way to the right of the table, to enable filtering and also visualization on the map. Finally, we will compare the scenarios through maps. Here we've opened a map named Transportation Routes, where we compare the predefined territory scenario with the no territories scenario. As you can see, all the customers are still colored based on the predefined territories, and you will see when zooming into the no territory scenario that some customers from different predefined territories have now ended up on the same route. Like, for example, this dark blue one, north customer with this red east customer, and also here a red and a light blue customer. There's another pre-configured map set up in this template model named Territories Transportation Routes, and here all the customers and routes are colored based on the territory they belong to. So 3 optimized territories on the left and 5 optimized territories on the right hand side. Again, you can zoom in and pan through to explore these routes further. We'll wrap up here. I hope you are encouraged to start using the territory planning feature yourself. So either copy this template model from the resource library and start working with it, or take your own Hopper model and add territory planning to it.